The nuclear power stations, with their large industrial concrete chimneys that we're all familiar with, have been serving the UK with electrical power for many decades. Many of these power stations and their associated facilities are coming to the end of their life and need decommissioning. Sellafield is the largest facility in the UK, where there are approximately 170 nuclear facilities which require decommissioning over the next 100 years, at an estimated cost of £85 billion. There are a diverse range of buildings, structures and glove boxes on the Sellafield site, each having their own decommissioning challenges. Buildings can consist of many rooms or cells, which contain a complex network of vessels, pipework and structural steel. The hazardous, congested environments, combined with difficult access, means that decommissioning and dismantling radioactive cells and glove boxes is a complex task. Manual decommissioning is hazardous for the operator and extremely time-consuming. Remote decommissioning is one option, but solutions are often bespoke and costly. The successful development of a simple remote deployment capability will facilitate safer, cheaper decommissioning and reduce secondary waste generation. This is where remote maintenance systems can help. The Modular Tube Deployment System is an apparatus that provides remote access to hazardous locations within a nuclear facility. The MTDS is designed to be a flexible, modular solution that can be adapted to enable different locations to be reached within a hazardous cell from a roof penetration. It creates a passive deployment route from the roof penetration to the desired location within the cell below. This deployment route allows tools and equipment, up to 5 kilograms in mass, to be deployed for tasks and activities to be undertaken. It's made up of tubes and joints, which are connected together in a series to form a deployment path. The tubes and joints are assembled and connected from outside the cell using the deployment system. The deployment system at the top is a series of modules. The middle module is a tube support assembly, which supports the tubes as we deploy them down. The second module, which is the winch system, allows us to hold the tubes during the assembly process. And the third module, which is the hydraulic inner actuator system, contains all the support services and control system for actuating the joints. Once they're within the cell, an inner actuator can be passed through the tubes, which can articulate the joints into a certain orientation. Once at the required joint to be articulated, the inner actuator aligns with the joint, locks in position and supports the mass. The inner actuator then releases the locking mechanism to allow the joint to rotate. The joint is repositioned by the inner actuator to a new angle, and the inner actuator activates the lock on the joint to fix the joint in the new position. The inner actuator can then be removed or positioned at a different joint. Any of the joints can be articulated at any time and in any order. This creates a continuous path down to the location that needs to be accessed. Through this path, we can send tools, sensors and inspection equipment to the location to perform the required activities and tasks. Once the tasks have been performed, the MTDS can be left in place for extended periods for further activities, or can be extracted through the reversal of deployment using the inner actuator and deployment system. The MTDS is failure tolerant and fully recoverable in the event of failure. The deployment application by remote maintenance system means that the operator is away from the hazardous areas and is able to deploy the full system from a safe place. While it leads to improvements in time and cost of maintaining some of those hard-to-reach areas, the deployment system has the capability to reach areas previously unreachable. To find out more about our modular tube deployment system, go to remote-maintenance.co.uk or email us at info@remote-maintenance.co.uk.